Okay, so I had a request for a quick video on what you would be expected to know about phase diagrams. And so here it is. Basically, like I mentioned in class, I'm not going to memorize hardly anything on phase diagrams. The only thing I really need to memorize is what's on the axes. And if I remember that the vertical axis is pressure and the horizontal axis is temperature, then I pretty much won the battle, right? Because then we're not going to make you draw one from scratch, but we might give you a skeletal phase diagram like this. Incidentally, this is a very typical kind of just basic structure of a phase diagram. If this were water, then that topmost line would have a slope to the left instead of up and to the right, but that's not important right now. But then again, I'm going to think to myself, hey, if you had a really, really high pressure and or a really, really low temperature, what phase would you expect to have? And the answer, of course, is that you expect that to be solid. And so I know that this region is the solid region. And then I'm going to do the opposite extreme. At very, very, very low pressures or very, very, very high temperatures, I'd expect to see a gas. And then that leaves just liquid to fill in the middle. And then just what's happening along these boundaries. Keep in mind, this is a static diagram. This isn't over time. It's just given pressures and given temperatures. And so this line here represents a bunch of pressures and their corresponding temperatures, which is the border between the gas and liquid state. In other words, at any given pressure-temperature combination along that line, we know that the gas and liquid states are at equilibrium. For every gas particle that condenses, there is a liquid particle that evaporates. And so they remain at constant values like we saw in our state change equilibrium example. So anywhere along that line, there is both condensation and evaporation happening at equal rates, and so we say that the gas and liquid states are in equilibrium all along that line, which is again where vaporization and condensation are taking place. And then we would, take you from mention this point right here where the three lines intersect. Then you can imagine all three states can exist in equilibrium, and so all three, solid, liquid, and gas, will exist in equilibrium at what we call the triple point. Triple, of course, being for the three different phases. And so that's of interest. And then another thing that's interest is this point. At the end of any of these phase transition lines is what we call a critical point. And to be honest, the only critical point that we're interested in this course is the one that's at the end of the liquid and gas line. There's both a critical temperature and critical pressure, but really, again, honestly, we're only worried about the critical temperature. We'll talk about that more in a minute. But then we'll give you a transition, right? We'll say that a material or a substance, a sample, goes from state 1 to state 2. And so what I mean by state 1 and state 2, by the way, is not the phase or the state of matter. I mean the state as in, we mentioned, state variables versus path variables, right? So, I mean it went from one pressure and temperature to a different pressure and temperature. All right, so as it goes from 1 to 2, you can imagine that's a constant pressure. So if the pressure doesn't change and you raise the temperature from state 1 to state 2, then what would you expect to happen? Well, at first, the temperature of the solid would rise, and then once it got to that transition line, at that pressure and temperature, the temperature would stop raising, and it would undergo heat of fusion, right? Latent heat of fusion in this case, as it melted, going from solid to liquid, until all of the sample was liquid state, and then the temperature would continue rising to state 2. So we might ask you to describe that transition. And then this is just what I mentioned a second ago, the critical temperature. Basically, above the critical point, it's called what we call a supercritical fluid. It doesn't behave like a liquid or a gas. It intermingles the properties of the two. What's most usually relevant for us in first year course is just that above that temperature, you don't get the properties of a liquid no matter how much pressure you apply. And so that's just an interesting transition point there. And so we rarely actually have you delineate that as much as triple point and then these other transitions, but those would be the only things that you might be expected to recognize.